Okay, this video is for section 8.1, where we're going to start talking about functions. So every function is a rule. It's just a rule that's happening. We're often going to see it written as f of x, which is called function notation. It's saying the function f in regards to x, where x is the input, and then y, or f of x, is the output. So if you put an x, you get y. For example, for this g, it's read g of x equals x plus 5. What that's saying is whatever we put in for x, we add 5 to it, and we get g. The verbal description. So if it's ever asking you to do verbal, that's putting it in words, or when you would see it is a word problem. Numerical is putting points into a table of values. So you might put x's in, plug them in, get the g, get the y. That's the numerical representation. The symbolic would be your equation or your formula. So this up here is a symbolic representation. And then graphical is either a list of ordered pairs. I don't know. My brain's not working. Ordered pairs or an actual graph. So if it's asking you for any of these specific representations, that's what it's talking about. So for here, we're given a verbal, and then we make the other one. So let function f square the input x and then subtract 1 to obtain the output y. That's our verbal. Symbolic would be the equation. So we're saying f of x squares the input. Then we subtract 1, and that gives us the output, which is y. So you could have written it like this, or you could have written it like that. Those are both the same. Make a table of values. So now we're doing our numerical. So if our x is -2, -1, 0, 1, and 2, we just plug those into that equation. So -2 squared would be 4, minus 1 is 3. -1 squared is 1, minus 1 is 0. 0 squared is 0, minus 1 is -1. 1 squared is 1, minus 1 is 0. And 2 squared is 4, minus 1 is 3. So now we have our numerical representation. And then sketching a graph would just be putting those points. So if this is our x and this is our y, that first point is -2, 3. The next point would be -1, 0. The next point would be 0, -1. 1, 0, 2, 3, and that right there would be our graphical representation. Evaluate. Like with our rational functions in chapter 7, we're just taking the number they give us and plugging it in. So here we're saying x equals -2. Now we solve. 3 times -2 is -6. -6 minus 7 is -13. The next one is 0.5. So we're saying 0.5 over 0.5 plus 2 would be 0.5 over 2.5. And because it's better to not have decimals in your fractions, if we were to type that right in the calculator, 0.5 divided by 2.5, you would either get 0.2, or if you hit math enter, you'd get the fraction of 1/5. Either of those would be fine. Now let's go to the last one here. We're going to plug in 10. So 10 minus 1 is 9. The square root of 9, remember, is positive and -3. You always get both. All right, let's keep going. So let a function f compute the sales tax of 7% on a particular purchase of x dollars. Use the given representations to evaluate f of 2. So verbally, we're saying multiply x dollars by 7%, or 0.07, to get the tax. Numerical would be a table. So maybe we're going to try $1, $2, $3. So 0.07 times 1 is 0.07. 0.07 times 2 is 0.14. 0.07 times 3 is 0.21, and so on. Symbolic would be our equation. So we're saying 0.07 times the money. And then the graphic, if we go over here and plot the points, we have 1, 0.7, 2, 0.14, 3 comma 0.21, and it's just going to be a straight line that goes up like that. Now we have our 4 things. The question is to evaluate for f of 2. So looking right at this table, we already have that answer. At $2, it's 14 cents. But we could do it with any of them. All right, let's look at another one. A function computes the median individual income in dollars in relation to educational attainment. This function is defined by, and then they give us f of n equals 25,000, f of h equals blah, blah, blah. So if we were to write those as a set of ordered pairs, we're going to put them in little swirly brackets. The first point would be n, comma, 25,376. So with no diploma, that's their average income. Then our next one would be H, comma, 34,736. So the high school diploma. The next one is bachelor's, 57,252. And the last point is master's, 68,952. So that would be our function listed as a set of points. Domain, if you remember, is all of the x values. So the domain would just be n, h, b, and m. Those are all the x values from those points. Range is the y values. So we're going to do the same thing. We're just writing the money. So we have 25,376, 34,736, 57,252, and 68,952. Now, discuss the relationship between education and money. So, as you know, I hope, that no diploma means you didn't finish high school. The next level you complete is high school. The next level is bachelor's. The next level is master's. Obviously, it's not perfect, but we're saying as we go to those different letters, we're moving up. And if we look at the money, it's doing the same thing. So, in general, the more education you have, the more money you make. Not always true, but that's typical according to these averages. So we talked about domain and range with points. Now let's do them on the graph. Domain is our x. So our lowest x value on this graph would be -3. Our highest x value is 3. Because those are not open circles, we would put brackets. So we can just write it as that interval. Range, we're going to do the same thing for the y's. The lowest it goes would be 0. And the highest it goes would be 3. So the range is 0 to 3. Now, looking at this graph, we're going to say there's arrows here. So our domain would be -infinity to infinity because it's going to go on forever in both directions. Range, we have a minimum. So the lowest it ever goes is -3, but it does go up forever. So that is -3 to infinity. So we can use our graph, our max and mins, anything like that, to do our interval notation and write our domain and range. Most functions have a domain of -infinity to infinity. Most of them go on forever in both directions with no breaks. There's a few exceptions that you can tell just by looking at your equation. For example, absolute value is never negative, so that domain would change. You can't have a negative inside the square root, so that domain would change. You can't have a 0 on the bottom of a fraction, so that would change the domain. But as of right now, if it's not one of those three, your domain's just going to be -infinity to infinity. So if we look at this first one, 5x, it's not one of those three, so that's the domain. And if you think about it, it's a graph, goes on forever on both ends. And the second one's a fraction. We know we can't have 0 on the bottom. So to find the domain, we just say x minus 2 can't equal 0. Add 2 to both sides, and we know x cannot equal 2. It's everything else. So in interval notation, that would be -infinity to 2 and 2 to infinity. So you could write it in either of those depending on what's asked. The last one here is a square root. We can't have a negative underneath, so we know x has to be greater than or equal to 0, which in interval notation would look like this. Functions, the big thing that makes it a function is you have one x for every y. So if every time you put in 1 for x, you should get the same y value out. So if we look at this table, we're trying to decide if it's a function. We have two values where x is 1, and we get different numbers. So this is not a function. If these were both the same number, it could be. But because they're not, it's not a function. Oh, I did here. Stop. Okay. With a graph, you can do a vertical line test. That means if you draw a vertical line anywhere on the graph, if you touch the curve more than once, it's not a function. So for this first one, the swirly one, there's no place I would touch that more than once if I drew a vertical line. If I drew a line here, I only touch it once. If I draw it here, I touch it once. Here, I touch it once. So this one is a function. The next one, if I draw a vertical line right here, I touch it in 2 points. Automatically makes it not a function. It doesn't matter if that does it once or 100 times. That one time makes it not a function. Now, if we look at this one, we have a vertical line. It's a line, it's a graph, but it touches all of these spots vertically, so it's not considered a function. All right, we're going to learn how to use our graphing calculator to enter a scatter plot. So when you're entering a list of points, you're going to hit the stat button, put the X values in L1 and the Y values in L2. So in my calculator here, stat is a couple over from the alpha, hit enter to go into your list, and then we're just going to type X values and Y values in here. You can clear lists, you can delete things out. Mine's a little bit different than yours, so I'm just going to clear these. Okay, stat, enter. You can arrow up to L1 and clear. We're going to put all of the Y values, or all of the X values, sorry, in L1. So I'm going to put -2, enter. Nope, go down. Sorry, clear. -2, -1, 1, 2. Now I'm going to do the same thing with the Y values, but put those in L2. -2, 3, 2, -3. Those are in. Now to make a scatter plot, to turn on that feature, we're going to hit the second button, which is the blue button, and then Y equals. And then you're going to hit enter to get into plot 1 if you're using an actual calculator. Now we want to go in and make sure it turns on. You can pick whatever color you want, and then you want your graph to pick the scatter plot. The mark doesn't matter. Just make sure your X list and Y list say L2. Now our scatter plot's on. Window is the viewing screen. So that's like saying if this is our axis, what's our X, lowest X, what's our highest X, and so on and so forth. So that's going to be written in parentheses or brackets down like this here. And what that is it's your X min, comma, your X max, comma, your X scale. So how quickly do your X's go up? And then the other one is the same thing, but Y's. Y min, Y max, Y scale. C-A-L-E. Wow. So this is telling us to type those in. So you hit the window button, which is up by the Y equals. We want it to say -4 for the min, 4 for the max, scale for the 1. We want it to count up by ones. And then Y min, -4, 4, and 1. Then when you hit the graph button, it zooms in to that, or it should zoom into your scatter plot. So stat, edit. I just want to make sure -2. Okay, put those in. -3, enter, graph. And then you have your dots like that. On a test, if you're showing me the scatter plot, you can do it by hand and take a picture, or you can just take a picture of your graphing calculator and submit that. That is just fine. That is 8-1. Let me know if you have any questions.